for the benefit of the people that are not, with us. And welcome back to the Launch and Learn. This is our third session on the Launch and Learn on the series of end-to-end machine learning project. So let's start. Let me see how I can do this. Okay, here we go. Okay, so the agenda, as we always do, is for people that are the first time that they have connected with us in the Launch and Learn. The purpose is to share situations, knowledge in the data science field. We give a couple of minutes for introductions. It's totally voluntary. Then I want to make sure that everyone knows where we hang out. We have a Discord channel, and I posted in the chat, I posted a link for an invite. So if you go there, you can join us there. Then we started this series about a month ago. It's called the End-to-End Machine Learning Challenge. And we're going through the steps of the phases of a machine learning project, from the business understanding, data understanding, exploring the data set, doing some features engineering, modeling, and then deploying. Okay, so I'll recap on the quality circle. I call it quality circle because it's, it reminds me of that. The circle of continuous improvement. So right now we are in the phase that we're going to be finishing the exploratory analysis, and we're going to be doing a couple of things that are going to be starting the feature engineering. Okay, so sometimes when you have a data set, you want to explore the behavior of your target. You have to explore it, but the variables that you have in a data set, they're not enough, or they have to be transformed, or you can create new ones. So we're going to give you some examples on how to do that. Okay. Let me go to introductions. Okay, so let's start with me. My name is Ricardo Serrano. Nice to meet you. I'm one of the co-organizers with Ron and Kevin on the Orlando Machine Learning and Data Science Meetup. I started with the meetup on 2019, but before and currently, I've been doing appraisal work. I work as a real estate appraiser and also personal property. My education is in industrial engineering, and I have a master's in engineering management. And I have been involved in data science since, the OMLDS, and also doing online courses. Okay. Do you want to introduce you, Ron?
Sure. Thanks, Ricardo. So I'm also one of the co-hosts or organizers of OMLDS. I got involved with the meetup group back in 2019. Also, my background is similar in undergrad in industrial engineering, but and then I have a math MBA. But through my career, I've been in various roles in software development, and then shifted into the data side of things, and eventually into machine learning, analytics, and AI type of work over the last really 5 years, I would say. At this point, I started trending in that direction. So, and I currently just run my own company, a consulting company called Adventurous Analytics, and have done some projects here in the local Orlando area, and actually some other clients around the nation at this point. So I'll hand it back to you, Ricardo, or anybody else who wants to introduce themselves. Yeah.
So this is the space that we allow members to introduce themselves. As I said, it's voluntary. We're not going to call anyone. But if there's a first timer in this session, please, just tell us, your name, who you are, and if you are doing something related to data science or related to computing in general. The floor is yours.
Yeah, I can go. I am Rishikesh. I go by Rushi. I'm currently based out of Tampa, Florida. I'm working as a data scientist for a company named Olive AI. So we are into healthcare tech space. So I did attend this one of the workshops, I think a couple of years back, and it just somehow slipped from my meetup link, and it popped up somehow last week. So I registered, and I'm looking forward to learning more and sharing in the future, in near future for sure.
All right. Welcome back. Rushikesh, right?
Yeah. Rishikesh.
Okay.
Yeah, that's right.
I got it. Okay. Welcome back then.
Okay, I can also say something. Hello, guys. I'm Remco.
Hello.
I'm a former astrophysicist from the Netherlands originally. So I did my PhD in the Netherlands, but I'm currently living in Orlando. And I'm actually trying to transition my career to data science. And as part of that, I'm also currently enrolled to start a Master of Science in Business Analytics here at UCF. So hopefully that will get me started properly into getting a real job in data science somewhere next year.
All right, excellent. Do you follow Neil deGrasse Tyson in Star Talk, Remco?
I don't really follow him, no, but I am
Okay.
aware of him, so I like what he's doing. But yeah,
I mean, I hear his podcast, regularly. So yeah, because you said astrophysicist, I said, okay, he's in the Neil, in the Neil club.
yeah.
All right.
So,
Okay, excellent. Welcome. Anyone else?
Yeah, so hey everybody, I'm Eugene. I just moved here to Orlando just a few months ago from California, and this is my first meetup with this particular group. I'm really here to really meet the local techies because again, I just moved here, so I'm just trying to get to know the people, the culture, and also, I've been in software engineering for about 20 years. Of that, last 10 years have been within the leadership, within the engineering space. But I have not really dealt so much with the machine learning and data science myself, although I play with data pretty much all my career. So I'm just here to learn some new stuff myself. Nice to meet you.
All right. Welcome, Eugene. Okay, glad to have you. And anyone else? Okay, so let's start doing something. Okay, so I posted in the chat, I posted that link. If you have any problems, sometimes the link expire, for whatever, app you're trying to access. If it's expired, please let us know. Okay, and I will send you a new link. But I hope that this one doesn't expire because I set it precisely not to expire. Okay, so you can join us there. We do the announcements usually there, the Discord, and also we can continue our discussion because this is only an hour, and we have we're constrained in time. But sometimes there's some doubt, there's some questions that maybe we can address using the Discord. So please, join us there, and let's try to continue the discussion. Okay. So this is the end-to-end machine learning. We chose a Kaggle data set. Kaggle, for those that they're not familiar with it, is a Google sponsored site where companies and even individuals, they post different situations using a data set, and then members can discuss the problem, can code, examples of coding, etc. And then we can improve our data science skills. So in this particular one, we chose what is called a credit card transactions fraud dictation. And it has certain challenges that are particular to that kind of business, right? The banking, finance, etc., that issue credit cards, they usually have to be on top, this problem of fraudulent transactions. Okay. We have a GitHub. We still have not posted the notebook because we want to first, do some exploration, do some analysis first, and then we'll, be posting certain notebooks that will help you in developing this these skills. And there's a Google Drive link that you can use to follow our coding exercise on the topics that we're going to be addressing today. Okay. And it's also posted in the chat. The Google Drive link I posted in the chat is at the beginning. All right, so let's see. Okay, so this is the timeline that we are trying, we're following. We already did 2 sessions of exploratory data analysis. We're going to wrap it up this session because we want to try to answer certain questions that may pop out, when you are doing your preliminary data analysis. And then, of course, we are going to be delving into feature engineering because we're going to create a couple of features that are not specifically in the data set. Then, eventually, we're going to be doing the modeling, right? After the feature engineering part, we're doing the modeling and then the deployment. And this is at the right, this is the, the circle that I was mentioning, which is, the source is called CRISP-DM, but it's a framework that is very traditional, very popular on how to manage a data science, a machine learning data science project, and what are the phases that you should be, following. Everyone should be following. Okay. Let me see what else. Okay. So right now, I think we're ready to continue. Let me stop sharing. Let me do this again. Okay, so this is the notebook that we have been working on. Okay, we already read the data set. We know more or less the variables that are coming from that data set. We did some modifications on the type, for example, the CC dash number and the zip code. The zip code, when we read the file, the type that was assigned, by the command was an integer. Okay, and we know that zip codes are not mathematically, you don't do anything with them. Okay, they are more labels. So we change it to the proper type. Then we did a little bit of exploration on statistics on numeric variables. We did some histograms on them to know more or less the shape of this distribution, etc. And I show you last time, let me see if I can check it out here. Okay, also with a library called Pandas profiling, we accelerated some of the things that we do in exploratory data analysis. We accelerated with that package, and it gives you a radiography of that data set in terms of the distribution of the each of the variables, what is the max, the minimum, the major categories if there's a categorical variable. There was a little bit of weakness in this package in terms of the interaction, and that's what we want to improve that. Okay, because in the Pandas profiling, the interactions, I don't know why they haven't changed the hex tiles that usually they confuse the reader. Okay, they don't give you an option for lines or for scatter plots, etc. And that's what we're going to be doing. Also, we study a little bit of the correlations, right? And it's important to see what is the correlation between target and the predictors, and also between each of the predictors. One of the things that we want to also improve in this is that even though it's a good indication, it's not visual, it's a good indication that they're doing a heat map for the correlation. Sometimes you want also the value, right? The value of the correlation to make sure that you get most of the information in terms of how correlated is each of those variables, right? So we're going to also be improving in that. So this is more like a first look of your data set. And it's good, okay, but it can be improved, all right? So let's see how we can improve this. So one of the things that usually when you start exploring the data set, any data set, you start looking at the variables, you start looking at, you know, some of the distribution of the target, if it's numeric, categorical, etc. And then you start asking certain questions. And some of the questions that I posted, some of them, you know, can be addressed using EDA, using exploratory analysis. So for example, which variables, the first question, which variables are more correlated with the target, right? Which is the indicator of if the transaction is fraudulent or not, okay? So when we go here, right, you know, to this diagram, and we choose the Pearson correlation, which is the numeric correlation, we see that in is fraud, which is the last variable, we see that amount has a higher correlation than other predictors, right? The other predictors, apparently, they're not very well, you know, related. They go to 0, okay? So we want to see more or less, you know, what's the numeric value of that correlation, you know, because we have something like 0.25, 0.20, 0.30. So we're not sure exactly how correlated that variable is, but it indicates that it's one of the most correlated ones. Also, if you follow me with MERC-LAT, that's the latitude of the location of the merchant, you know, when the transaction was posted, right? So in MERC-LAT, you see that there's a high correlation with latitude. In other words, you have latitude, one variable, and then you have MERC-latitude, merchandise latitude, as another variable. What is happening is that when the data set was produced, those variables are basically having the same information. And there's a phenomenon called multicollinearity, especially in regression, that usually you have to deal with it, the multicollinearity. And sometimes you have to choose one of them, okay? So that's information that you can gather just for looking at these, you know, visualizations that the pandas profiling is giving, okay? Another question. There's a variable called Unix time, okay? And I left that, you know, to your curiosity in terms of how do you change Unix time to a normal date, right? So basically the answer is that Unix time is the number of seconds that have elapsed between January 1, 1970, which is, that's the day that it was, you know, assumed as the creation of the Unix system. So January 1, 1970, all the seconds that are elapsed to the date that is, you know, that is portrayed, right? So what you have to do basically is manipulate those total of seconds into a date, all right? And there's a way to do it, okay? In fact, you know, I have it right here. If I do this, okay? If I do this, this function PD to date time, and I give the variable df raw Unix time and the units in seconds, it will then convert that Unix time into a date. So for your curiosity, try to compare that Unix time with the transaction time. What information is giving? Is it giving you the same information as the latitude and the merchandise latitude, or is giving you some other information? Because if it's giving you the same information, you can get rid of it, okay? You know, we don't want redundant information here. We want specific information, okay? Remember, machine algorithms, they are very sensitive to that issue in the multicollinearity, especially if you do logistic regression in this case, or if you do other distance algorithms. Another question. That variable of amount, the amount of transaction, do you think is relevant to detect fraudulent transactions? And I leave that open, to your, to your comments. Do you think we should explore that? What do you think? Yes or no will suffice.
Yeah, yes.
Right. For example, Remco, do you think that the amount of transactions, for example, higher transactions would be more, prone to be fraudulent transactions, or smaller transactions, smaller amount transactions? What do you think?
Yeah, my first instinct says that the higher ones are probably the high probability. Yeah.
Exactly. Okay, so yeah, I agree with you. Okay, but we have to, we have to investigate that, right? We have to do some experiments. We have to investigate to see if our assumptions are, are validated. Okay, with that, with that presumption. And also, and this, we're going to do it maybe in a later session, but from the dates, we can extract a lot of features from the dates. For example, can someone give me an example of what features can we extract from a date? Just the date, not the time. Okay, just the date.
You can do day of week, month, day of year.
Yep.
In the retail world, there's this thing called the 454 calendar. So they try and match up year-over-year comparisons. You might want to look into that type of realm also.
Exactly. So we can, create, a lot of features there. Okay. The thing is that once we create a feature, we have to compare to something, right? So usually we can compare with the, with the target, and we can do that analysis. All right. In fact, you will see that one of those features is going to be helpful in our modeling, to detect those fraudulent transactions. All right. Then, what features have a high correlation? Are these features redundant? We did an example of the MERC lat and the lat, and also you will see that the MERC long and long has the same, the same issue, that they are very highly correlated. Okay. Okay, so let's try to, improve that correlation. So we have, okay, we're dealing with the sample. Just a sample is about 30% of the data set, just to make the calculations, faster. So we can do something like this, right? Okay. We can use the core function, right, to get a numeric correlation of all those of all those features, the correlation between themselves, right? So let's see what happens here. Okay, so here, what the output gives you is a numeric value of the correlations between those numeric values. And because it's fraud, the label is in numeric form. Okay, it's in zeros and ones. Is also part of the mix. So one thing that we can see is that, remember that the amount was the highest correlated feature to the target, the fraudulent indicator, the fraud indicator. So right now we have a number of 0.2071. That means that 0.21 is the correlation between that feature. Also, remember the latitude and the MERC latitude? Let's see numerically what is the correlation. And you see it right here, 0.99, almost 1. Okay, so basically what it's saying is that they have the same information. It's just a little deviation, but it has the same information. So you can get rid of one of them, and you're not going to be getting rid of vital information because it's redundant. All right. And also you can do the same with the Unix. With the Unix, you will see that the same information is taken from the transaction, date. So probably the Unix time, it won't add any more information to our, to our predictors. Okay. But remember that we want to, make it a little bit more comprehensive. So if we can combine, right? If we can combine that heat map with the labels, then we have the best of both worlds, correct? Okay. So we're going to use a function from the Seaborn, library, which is heat map. All right. And what it's going to do, that function, is that it's going to give us the heat map that the pandas profiling, showed us. But then we're going to get those labels within each square of the heat map. So let me, because I usually don't remember, exactly the functions. I'm just going to do a little copy here. Okay, so we have the whole thing. Okay, let me see. Okay, this is the function. Okay, SNS Seaborn heat map, and then all these arguments. So let me copy this here. Okay, and cross fingers. Okay, so now we got a nice looking, right? We got a nice looking heat map, but also you get the labels, right? And we're trying to see which are the features that are highly correlated with our target, the fraud indicator, right? And we see that amount, now we see the color, but now we see the number too. Okay, so we have the whole information to do that. And the same thing with the latitude, right? The Merck latitude and the latitude. You see here 0.99, all right? So with this function, basically we kill, two birds with one stone. I mean, hopefully PETA won't, I won't get into trouble with PETA there. All right. Okay, so there's others correlations they don't use the numeric for value, they use rank. And the two most traditional with rank is Spearman correlation and Kendall correlation. So let's go back to this, a notebook here. And if you want the Spearman correlation, by default, that core function in pandas, it gives you the Pearson, the numeric one, okay? If we want the Spearman, we have to add an argument that is method Spearman, right? And what we want to see if there's any difference between the numeric correlation and the rank correlation according to Spearman. So let's see if there's a difference, okay? And let's look at the is fraud. So in the fraud and amount, remember that in the numeric we had 0.21, right? Here we have 0.087. In other words, according to the rank, they are not very aligned. According to the numeric formula, they are, more correlated. But according to the rank, they are not. Okay. And if we go to the Merck lat and the lat, we'll see that the numbers didn't change that much. 0.99, 0.1. So numerically and by rank, they are the same. All right. And we can do the same thing with the Kendall correlation, which is another formula that is using also rank. In other words, the order of those values. Okay. So to do that, we're going to do the same function here, but instead of Spearman, we're going to say Kendall. Okay. right? So there we have all those three correlations, and let's see what happens with the fraud and the amount. It's a little bit lower than the experiment. Okay, so we have a numeric correlation of 0.21, a Spearman correlation of 0.08, and a Kendall correlation of 0.07. Okay, and also in the Merck lab, you will see that the correlation is less too. So in terms of the ranking, there's kind of a disassociation with it that you're not seeing in the numeric. I think there's a hand raised. Yes.
Yeah, I think this is an example where AI decided to interrupt your programming there, Ricardo. You raised your hand,
Okay.
and automatically put it on the screen for you.
Ah, okay. Did I do that?
Yeah, when you raised your hand,
Okay.
it saw it in your image and created it.
Oh, okay. Oh, that's weird. All right. How do I take that out? Anyway, that's okay. All right. So we have a function, a very nifty function from Seaborn, the heat map, that gives us the colors, right? You know, depending on the magnitude of the correlation. We have the values of the correlation, and also we have different, types of correlation. Okay, that could be useful for our analysis. At least for now, those are the takes. That amount is the one that is highly correlated with is fraud, the fraud indicator, and also that Merck lat and lat have this information. Merck long and long also have this information. Okay. Now, one of the things that pandas profiling doesn't do very well, okay, is those interactions. And that's important because that's part of what is called bivariate analysis. In other words, we are going to be comparing two variables, okay, for this analysis. Since our target is categorical, it's important that we understand that there could be a categorical to continuous analysis and also a categorical to categorical analysis, right? But first, we're going to start with a continuous to continuous, right? To get the whole, the whole permutation here. So we're going to choose, right? We're going to choose amount, and we're going to create a new feature, okay, here, that is called age. How are you going to create that feature? Well, there's a variable in your dataset that is DOB. DOB stands for date of birth, right? So what you can do is for each of the transactions, you can manipulate that date of birth subtracted, right, with another date to get the age, right? So one of the things that you can do to get that age, at least, a preliminary age, because you can do it in different ways. One of the things that you can do is take that transaction date of the transaction and then compare it with the date of birth, okay? And you can also define which of the transactions date we are going to be choosing. In this case, we're going to choose the minimum age, the minimum transaction date, okay? Because it makes sense, that when the customer did a transaction and did the first transaction, automatically it can give us the age with that DOB, right? Following me there? Okay. All right. So let's go back to this notebook, and we're going to do this function. Okay. And I'm going to explain more or less what I'm doing here. Okay, so we want to calculate the age subtracting the minimum transaction date to DOB. Okay, that's one way to do it. This is not the only way. Okay, you can, for example, say, okay, I'm going to choose the middle value of that range of dates. You can do that too, okay? In this case, we're going to, stick with the minimum. And in my case, it makes sense because that tells me that the first transaction that person did, I want to check that age, okay? And there could be problems because, for example, if I find an age that is kind of like a children age, let's say 5 or 6, that is troublesome, right? Because children shouldn't be doing that kind of transactions. They could be a fake customer, okay? So I want to make sure that I get that information, all right? So the way that I want to do it is, we got the DOB, right? Our variable date of birth, and we already changed it to a date format at the beginning when we read the data set. Then we're going to also take the transaction date, okay? Let me check if I have the transaction date. Okay, I have to do this first. Just make sure that I have the transaction because I just want the date component of that transaction because it has date and time too. So let me do this. Okay, so we have the transaction date and we're going to choose the minimum. In other words, from those dates, I want the minimum date of that transaction, of those transactions. Then we're going to do a transformation here because when you subtract those dates, you still have a date, okay, a date value. So we're going to transform it to a year. For that, we're going to use the function time delta. The time delta transforms a date to seconds, minutes, hours, dates, and so forth. In this case, we're going to do days equal to 365 to calculate the years, okay, the years. And then we're also going to say that the type of that value is going to be numeric, integer, instead of a float, in other words, okay? So let's run this, right? And let's take a look at that, at that new feature. Okay, age, right? Let's do an histogram. Okay, so here's our histogram, right? And what is the range of the ages? Well, the range of the ages is around somewhere around 14 to 15 years, more or less, right? And then up to, some value here, 100. If you want to see the numeric values, you can do this with this this function called describe. Okay, describe is going to give you a couple of statistics for that numeric value. So let's see here. Okay, sorry, age. All right, now give me the variable. Okay, and it says, okay, the minimum value here is 13. Age 13. Okay, and the maximum value is 94. So is it possible that a 13, 14-year-old can buy from a credit card? It could be. It could be. If it was 5, 6, or 7, I will be a little bit suspicious, right? Okay. But 13, 14, you have students that have, some access to a credit card to learn how to manage, financially. So yeah, that could be possible. All right, but this is the first step. We haven't finished. We created our feature. Now we want to compare it, right? We want to compare it with the target, with isFraud. So how we're going to do this? Okay, one way to do it is through box plots. Okay, so we can say, okay, give me a plot, right, that gives me a box plot for age with the transactions that are not fraudulent and compare it with another box plot for the fraudulent transactions. Getting the age as the variable that we're going to be studying. Okay, so how do we do that? Well, we can do it in different ways. Okay, so let me see here. Okay, here we go. Okay, box plot age, right? By this fraud. Okay, so in Seaborn, you have a function called box plot, and in the function you can assign two variables. Okay, one is going to be kind of a categorical variable, and the other is going to be a numerical variable. Okay, is fraud is categorical, age is numerical, and the data. So let's see, what do we have here? All right. So right from the visualization, we can see that there is a difference in the median, right? In the 50%, 50% range, the second quartile. And as you can see in the transactions that are not fraudulent, we see that the median of the age is lower than the median when the transaction is fraudulent. Okay. So the question is, okay, is this something that is significant to our analysis? Because we see a difference, but we want to know if it's statistically significant. So we have to do kind of a hypothesis test, right? A t-test in terms of trying to see if that median, if it's equal, that's going to be our null hypothesis, or if it's not equal. Okay, so for that, I already have a function that gives you not only the box plot, but it gives you also that hypothetical test too. So let me run it here. Okay, let me see if I can run it here. Okay, that's the function. And then, okay, cross fingers here. Okay, I haven't created the age here, so let me create the age. Okay, that's the age. And then let's see if I can run this. Okay, here we go. Okay, so we got from the Seaborn function, we got this, right? That categorical box plot with the age group in the transactions that are not fraudulent and the transactions that are fraudulent, right? But in that function, we get a t-test, a p-value of the t-test, and also we get a p-value of the c-test, right? And what it's saying here is that usually when you deal with p-values, your threshold usually is 0.05. Okay, in other domains, it could be less than that, but let's stick with 0.05. So what it says is that if your p-value is less than 0.05, that means that there is a statistical significance between the relationships between those both groups. Okay, in other words, it's statistically significant. You reject the null to in favor of what is called the alternate hypothesis. The alternate hypothesis is the one that says that they're different. And because they are different, that means that age is going to be a good predictor for our target, which is fraud. All right. Any questions comments there. Okay, so visually, we know that there's a difference. But if we do a statistical test, a t-test or a c-test, then we got more information about that difference. And that difference is telling us that, yeah, statistically, yeah, it's different. Okay, in other words, they're not equal, which is the null hypothesis. All right? Good. Okay, we skipped something in the notebook. We skipped something, and it was the relationship, the continuous relationship between age and amount. Okay, which was the continuous to continuous, right? So let me do this. Okay, let me see if I can split it here. Okay, let's do this. Okay. Right. Amount and age. Okay, so amount and age, we want to know what is the relationship between how old you are and what kind of transactions, amount transactions you are doing. So for that, we need to do, because they are both continuous, we need to do, we can do it in many ways, but the most traditional plot is a scatter plot, okay, because both are numeric. So let's do this. Let's do a scatter plot, right, of age and amount. Okay, using, again, the DIE library, Seaborn. So the function is scatter plot. Again, 2 arguments, okay? We're going to have in the x-axis, we're going to have the age, and then in the amount, we're going to have, in the y-axis, we're going to have the amount. All right, so let's run this and see what happens. Okay, so this is the plot. All right. We can add a regression line, okay, to see if there's a trend. Because if there's a trend, that means that one variable, could be, is influencing the other, right? Okay, so that there's a, there's a relationship with it, just as, the correlation. So let's do that. Let's add here a regression line. Okay, don't go there. Okay, so for the regression line, we're going to use a function called regplot. Okay, it has the same parameters. The only thing that now we added some parameters to change the color of the line, the type of line, alpha for the opacity, etc. So let's do this. It's going to take some time, even for the sample. Okay, there are about 400,000 observations. So, but it's coming. It's coming. I have to put like a Jeopardy, jingle. Come on, you can do it. You can do it.
Ricardo, you broke Google.
I know. I broke Kaggle. Okay, here we go. All righty. Okay, so that's the regression line. What do you think, guys? If that was a EKG, man, we're in trouble. Okay, so what do you think a flat line means? In other words, there's no slope, there's no trend or anything like that. What do you think it means? In fact,
yeah, it means there's
go,
no.
go ahead, Randy. I didn't catch that. Go ahead. Repeat that.
It means that there is no correlation. But I'm also wondering if you can actually, can you print out what the slope actually is?
What was that?
Can you also print out what the parameters of the regression line are, like the slope?
Okay, I have to check, if that function gives you that information. Okay, if that function, I'm not sure. I'm not sure. But just visually, you see that there's a flat line. In other words, there is really no, one is not explaining the other. Okay, and it's behaving like a uniform, right? Like a uniform distribution. In fact, because we have our correlation. Remember the correlation that we have? Okay, it's in the same data set. The only thing that we are now have age. So if we run this again, we're going to have the age, correlation too, right? So if we run it now, okay, now we have age here, right? Okay, which is at the end of the spectrum. And as you can see, H and E is fraud. The correlation is 0.01. Okay, so apparently age is not, a great addition, to our predictive power. Okay, so we'll have to see, if we can do something else to age, maybe convert into a categorical. Okay, or it could help explain other phenomena. All right, but definitely age is not. And remember, that's the tricky part here. Okay, when you create a feature, that doesn't necessarily mean that that feature is going to help in your in your quest for a predictive model. You have to make a judgment, right? So sometimes it helps, sometimes it doesn't, or you have to keep manipulating those features. So how much time you run? 5 minutes? Okay, so the last one that I had for you, we're going to continue in the next one, because right now we're getting into the feature engineering, right? We're analyzing the data set, but we're creating new features now. So when we come back, we're going to do the category, because in the category, there's some interesting, categories that you should be aware, but also Ron is going to give us, a session on how to use, certain packages, certain libraries in Python to extract a distance from the coordinates. Okay, and what we're going to do is that, remember the lat and mertlat, that they have the same formation. Okay, so we're going to get rid of one. We're going to work, let's say, we're going to work on the latitudes and longitudes of the transaction, and then compare it with the home address of the person that is doing the transaction. Okay, and the hypothesis is that the farther the transaction was made, the most probable transaction could be fraud. Okay, that's the hypothesis, but we have to experiment like we did with age. Okay, so that's the next session that we're going to do. In the calendar, I think we decided that about 12, right, Ron? July 12th?
Because if we went with our 2-week pace, it would be on July 5th, which is right after the holiday. We know a lot of people travel that week. Right. It's the heaviest travel week of the year. So we're going to go ahead and push it out to July 12th will be our next lunch and learn session. And that'll be posted on the OMLDS meetup site as well as in the Discord channel.
Exactly. So in that session, Ron is going to talk about, how to calculate those distances. Okay, and then do the same analysis, try to see if there's a difference, in terms of amount, fraud transaction, etc. And then probably we are already ready. Okay, with the feature engineer, we're already ready to, start the modeling phase. Okay, and see if our predictors are enough, to get a good model, or we have to go back. All right. How do you like it so far? Good. All right. So,
Great. Well, it was good seeing everybody. I'm sorry to wrap up quickly. I have to wrap this up because I have another call coming up not too long from now. And we will hopefully see everybody again in 3 weeks this time.
in 3 weeks. All right. All right.
Okay,
Take
take
care,
care,
guys.
everybody.
You guys.
Bye-bye.